Okay, this lesson is about combinations in mathematics. A combination is when tells you how many ways you can have a set of objects and choose a subset. So if I have 6 objects, I could pick any 2, and that would be one pairing, but I could obviously pair other ways as well. The formula generically is this. The particular example says if I have 6 objects and I want to choose 2, then it can be done in 6 factorial, which matches that, divided by 2 factorial, which matches that, and then 6 minus 2 is the 4 factorial part. If you do the simplification, that comes out to be 15 possible combinations. The mathematics of 6 choose 2 is the same as 6 choose 4. If you look at the numbers, 6 factorial, 4 factorial, and 2 factorial is still 15. So let's look at a particular example. If I have 6 points, I've arranged them in a circle, but they could be any 6 points. If I think about how I could choose pairs of points, I can actually make a list, and hopefully a conclusive list if you organize it. A could go with B, A could go with C, A could go with D, A could go with E or F. And I think that takes care of A. Then we could have B goes with C, B could go with D, B could go with E, E could go with F. Move on, C has already been paired up with A and B, so C could go with D, C could go with E, C could go with F. Moving on, D could go with E, and D could go with F, and finally E could go with F, and that's it. So we could count 5 and 4, 9, 12, 14, 15. There are 15 pairs of points. Now you could think about that as, we just saw it as a combination of 6 points, choose any 2. We just did the calculation above, and that was 15, and it turns out to be the same as the listing as we have. We can also draw them and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that was already in there, 13, 14, 15. And if you look, that's 5 from every vertex. 5 times 6 is 30, but we are also A and E are the same as E and A, so if we divide by 2 for the double counting, we get 15 line segments that we just counted. So that's a combination of 6 objects, choose 2 at a time. All these questions are basically the same question. If you have 6 cards, how many different pairings are there? A mathematician would just say, well, 6 objects, 6 cards, choose 2. If you have 6 possible pizza toppings and you're going to make a pizza, how many different pizzas could you make that have 2 toppings? There are 6 different toppings, 6 choose 2. If you have 6 people, how many different handshakes could you have? There are 6 people, choose any 2 and have them shake hands. If you have 6 protesters out demonstrating about something, you could have them, and you want to check 2 for the media. It doesn't matter how you pick them, it's still going to be 6 choose 2. This is a little bit different. If you have 6 points and you want to select any 4 to make a quadrilateral, it's going to be 6 choose 4, but we showed above that's the same as 6 choose 2. And that's worth just a quick little mental check. If you have 6 points and you choose these 2, that's one of the 6 choose 2 you could choose. By default, in picking that, you are also picking these 4 points to make a quadrilateral. So by picking any 2, you are in effect picking the other 4 to make a quadrilateral. So 6 choose 4 and 6 choose 2 are just the inverses of each other. When you pick 4, you're also picking 2 that you've left out. So these are both 15. That's combinations. We have some example problems for you to work. and I think you'll enjoy them.